Assalamu alaikum. Welcome to the first lecture of chapter 6, bulk deformation processes. Right? Just as a reminder, chapter 1 was introduction. Chapters 2 and 3 are not included because they are on material properties and so on. Chapter 4 is post manufacturing chapter about surfaces, quality and so on, which we have done. Chapter 5 was the chapter on casting processes, right? So now this is chapter 6, bulk deformation processes. I'm showing you this classification of manufacturing processes from the first chapter when we were introducing the whole field of manufacturing. So if you remember that manufacturing was processing or assembly, two big divisions. In processing, the main thing was shaping processes, all the major manufacturing processes where we change the shape. In that, solidification, where casting type of things are there, particulate, where we start with particles, we have not done something like that yet, and now deformation processes, bulk deformation. Material removal, remember we told you, is machining. So that was done in your workshop 1, workshop 2 and so on, lathe machine, milling machine and so forth. So this we will not cover officially as a chapter. Particulate processing we are not covering. So the two major manufacturing processes that we are covering is solidification type, which was casting and so on, and bulk deformation type, which we are now doing, and material removal or machining you have already done, right? So I just wanted that in this whole scheme of manufacturing, the whole world of manufacturing processes, where you are right now. I'm just showing you as an example, these will be full topics covered, that one of the techniques in bulk deformation is called forging, right? I am showing you a real big forging press, schematic, that there is an upper portion of the die, there is a lower portion of the die. The material which is preheated is somewhere here, and then it is forced by a ram or a press so that this material takes the shape of the die, combined upper and lower die, right? And here if you can see, right, a huge big thing. So it is not molten, it is not room temperature. It is at high heat, red heat generally, and then you do it. So this is called forging. You know that, we have introduced it earlier. This is called rolling, schematically, right? That there are rollers, and you pull or push the material through it. In material science, when you are doing material science in one of the labs, you are given some pieces and you go to the workshop, to the rolling machine, and you roll it to different thickness. And in the real world, big operations, right? Rolling can be done hot rolling or cold rolling, and this will be rolled through those big rollers and so on. So this is rolling. This is also one of the bulk deformation process. This is extrusion, right? As a schematic diagram, the die is here, here is the shape of the die, and there is a big press, so you force the material through the die, it takes the shape of the die, but it is now continuous. It is not like forging where it stops. This same shape now continues for 2 meters, 3 meters length and so on. And this is a real extrusion press, a big extrusion press, and after extrusion it is rolled out onto a very long length. So forging, rolling, extrusion, these are all bulk deformation processes, right? So I'm just showing you each one of them we will cover in a lot of detail. So this is a very big, long chapter which will continue for quite some time. So don't worry about what are the details of each of these. So with that background, that you see some pictures, you see some real world industry and so on. So what is bulk deformation? Bulk deformation. If you remember, in introduction chapter, we have explained that solidification process means that you will melt something and then solidify it inside a die or a mold. So any process like sand casting or die casting or all of those come under the big umbrella of solidification processes. Material removal, all the machining processes, lathe machine, milling machine, grinding machine, all those where you remove or cut away some material, again come under a big umbrella called machining processes or material removal processes. So these are two. Now, if you don't cut or remove any material, if you don't melt anything and still do manufacturing, then this is bulk deformation. That we will take a material in a bulk form like a plate or a big cube or a cylinder, right? Any starting material, and then apply a lot of force on it together with heat or without heat, but not melting, right? And we can convert a plate into a box. We can convert a cylinder into a smaller cylinder or into a pipe and so on, right? So you are changing the shape of the bulk material without any melting and without any material removal. So this is called bulk deformation, right? So this is what we are saying here. Now we can read it, that there is a stock material. A stock means the original raw material. Any process that changes the shape of a raw stock without changing its phase, that is without melting it and without removing any material, this is called bulk deformation, right? Another name is metal forming. Bulk deformation is one big name, or metal forming. Now, bulk deformation could be for plastics also, for other materials also, but majority of this will be done on metals. So when you do bulk deformation on metals, then you can call it metal forming. This is again a big, huge field, metal forming. So you do extrusion or rolling or forging of metals, not of other materials. You can call it metal forming. Forming means shaping, isn't it? So metal forming operations which cause significant shape change by deforming metal parts whose initial form is bulk rather than sheet and so on. So this is called metal forming. The tool is usually called a die, applies stresses that exceed yield strength on metal. This is not usually correct. You see, the application of a stress is by a hammer or a press, but a hammer or a press forces the material through the die. So it is not correct to say that the tool is called the die applies stresses. No. The whole machine, the whole equipment in which there is a ram or a hammer or a press, call it whatever, that applies a force which forces the material into the die, right? So it is not that the die forces the material. The press or the ram or the hammer forces the material, and the material is forced into the die or through the die. And of course, there is a lot of plastic deformation. Whatever material is there, we apply so much stress that it goes beyond the yield stress and remains below the ultimate stress, isn't it? If it goes to ultimate stress, then very quickly it will fracture. So you remain safely below ultimate stress, but significantly above the yield stress, and you do plastic deformation and you change the shape. The material is deformed to obtain the desired shape with almost no wastage. This is important here because we take the material and we directly change the shape of the material. So it is not like casting where you melt and solidify into a shape, so then it will not be exactly into the final shape and there will be allowances for shrinkage and this and that. But we are saying almost no wastage, because even after forging or extrusion, sometimes, rarely, but sometimes we may need to do final finishing operations. And the required pressures are generally high, because you see, we are not cutting, we are not melting. So then we have to apply a very large force so that the material takes the shape of the die. So very large pressures are generally required, and therefore the tools and the equipment needed are quite expensive, because we have to have a press or a ram or a hammer, and we have to have a die, and the die has to be so strong that we are forcing the material all the time through the die, and this die should still be working for hundreds or thousands of pieces, right? So the tools and the equipment are pretty expensive. Large production quantities are often necessary to justify the process, because now you have a whole equipment system, including the press, including the die, including the heating chambers or ovens or furnaces or whatever. And after it is done, then the whole tables on which it will come out. So there is a whole big thing. So therefore the cost of the initial setup will be very large, and therefore unless you keep on producing hundreds of pieces or thousands of pieces, then it is not cost effective. If you have to produce only 4, 5, 10 pieces, then you cannot have a whole extrusion press. You cannot have a whole forging press for only 4, 5, 6 pieces, right? So generally you require a large number of pieces to do that. Bulk deformation processes can be classified as primary or secondary. Again, we have defined that in the beginning in chapter 1, but once again, primary processes reduce a cast material into slabs, plates and billets, and secondary processes reduce shapes into finished or semi-finished products. What are we saying? For example, in a steel mill, the ore is coming, the rocks and so on containing iron, they are crushed, they are melted, they are taken through certain chemical reactions, other materials like carbon and so on are added to it, and then we get a steel, right? But after producing that steel, what do? They solidify it into plates or sheets or cylinders, right? So manufacturing is already being done, right? That they are being cast into certain shapes, but these shapes are not directly used. This is primary manufacturing. But then from a steel mill, some people buy sheets and convert these sheets into other shapes. Some people buy plates thicker than sheets and then convert them into something else. Some people buy cylinders and then convert those cylinders into other shapes. So that is secondary processing. For example, here in Oman, in Sohar, you have Valley Steel, a Brazilian steel company, and that will be producing basic steels and giving you rods and plates and so on. And then suppose in the Muscat region and so on, there are rolling mills or re-rolling mills. Rolling or re-rolling mills. So you will take the plate, take it to the rolling mill and change the shape. You will take a rod, take it to a rolling mill and change the shape. Now this shape will be the final shape that is being used by construction industry or other places. So Valley Steel in Sohar will be a primary manufacturing place, and the rolling mills here will be a secondary manufacturing. Similarly, in Sohar, the aluminum, Sohar aluminum, there are more than one companies which are joined together to make Sohar aluminum. They are producing basic aluminum from raw material. But then companies like NAPCO, the extrusion company in Russell, take that aluminum rods and billets and so on and convert them into final shapes of windows and doors and so on. So this is primary manufacturing and secondary manufacturing, and bulk deformation can be both types.